Right, we are busy with equations. We're starting with lesson 2. Just a quick reminder, we must keep the balance at all times. If we do something on the one side, we must do exactly the same on the other side of the equal sign. So let's quickly recap on the way that we solve equations. Number 1, I isolate x by using the golden rule of equations, which we just stated. Whatever you do on the one side, you must do exactly the same on the other side. If there's brackets, get rid of them by expansion. If there are fractions, get rid of them by multiplying both sides of the equation as a whole by the lowest common multiple of the denominators. When you divide the denominators away, make sure that you multiply the entire numerator if it has more than one term. Be cautious of negative signs in front of these fractions. Number 5, if these brackets and fractions, get rid of the brackets first. Then you deal with the denominators. When the unknown is found in the denominator, remember to check your solution in the original equation. You may cross multiply only when the equation is a single fraction equal to another singular fraction on the other side of the equal sign. Right, let's look at an example of linear equations. Firstly, I'm sitting with a fraction here, another fraction here, and 13 on this side. In order to get rid of this fraction, I will have to multiply by 4. In order to get rid of this fraction, I will have to multiply by 9. So, if I multiply this by 4, I will be left with x minus 5. But then I must still multiply by 9, so that means I'll be left with 9 times x minus 5. For this one, I must multiply by 9, but then I must still multiply by 4. So I'm working with a minus, and then it will be 4 multiplied by 3 in minus 4. On the other side, I must multiply by 4 and by 9, so there's nothing to cancel out. So that will give me 9x minus 45. This will give me minus 12 and positive 16x. 13 multiplied by 4 multiplied by 9 gives me 468. So, if I add the like terms together, I get 25x. 45 minus 12 is minus 57. That gives me equal to 468. So I want to isolate x, so I have to add 57 on both sides. Then I'm left with 5x. 25x is equal to 525. Divide both sides by 25 and I get x is equal to 20. Let's look at the next one. Here I will have to multiply by 6 firstly to get rid of the 6. So what I do on this side, I must also do on that side. So I'm going to do it step by step first to show you what happens here. Because I multiply by 6 on that side, I must multiply by 6 on this side as well. Then to get rid of the 3, I will have to multiply by 3 on both sides. Although 3 is a factor of 6, I did not have to, but I will multiply by 3 just to show how they cancel out. So what happens is 3 will cancel out 3, 6 will cancel out 6, then 3 must be multiplied with this, and 6 must be multiplied with that. So then I'll have 6 into 2x minus 1 and 3 into 3x minus 4. So when I expand, I will get 12x minus 6 and I'll get 9x minus 12. Simplify, bring the x's to the same side, so that will leave me with positive 3x, and add 6 here, I'll have minus 6. Divide by 3 here, divide by 3 here, x is equal to minus 2. Now one of the rules said, if there's a singular fraction on the one side and a singular fraction on the other side, I may cross multiply, but only if it is a single fraction and a single fraction. So let's cross multiply. 6 multiply with 2x minus 1. 3 multiply with 3x minus 4. I get exactly the same scenario on both sides, just without all this extra pt. So you can go into the answer straight away. Let's see how this will work out in the next one. Step by step, let's do this. Firstly, I will multiply with x on both sides to get rid of the x underneath the line, right? Then I will multiply on both sides by 4 to get rid of the 4 underneath the line on the left hand side. Multiply by 4, right? So then 4 will cancel out the 4, x will cancel out the x. Now I'll be left with 5 multiplied with x gives me 5x, and 3 multiplied by 4 on the right hand side. That will give me 12, and then I divide by 5 on both sides. So that will give me 12 divided by 5 on that side. And on that side I'll be left with x. So my answer is 12 over 5. Let's see, when we did this, a singular fraction on this side, a singular fraction on this side, cross multiply, I'll get 5x. Cross multiply, I'll get 12. So that takes me to my answer straight away. Don't have to stress about it. Divide by 5 on both sides, x is equal to 12 over 5. With this one, we don't have a singular fraction on the left hand side, so we can't do cross multiplication to lessen our load. We have to do this step by step. So here's a 2 term, here's a 2 term. Here I want to get rid of x. I need to get rid of 10. I have to get rid of 2x. And then I've got another term here which will be multiplied with all these things at the bottom. So in order to work this thing out, if I multiply by 2x, I'll get rid of this 2x, but I'll also get rid of the x here, and I still have to multiply by 2. So then I'll have to multiply by 10, but whatever I multiply by with for this term, I need to apply to this, this, and to this. That's very important. So I will have to multiply by 2x, and I'll have to multiply by 10. So for the first one, if I multiply by 2x and 10, I'll cancel out the x, but 2 will remain and 10 will remain. So I will multiply by 3, multiply by 2, multiply by 10. For the second one, the 10 will fall away, but I'll still have to multiply the 9 with by 2. For this one, if I multiply with 2x, 2x will cancel out, so I still need to multiply by 10. For this one, last one, I'll have to multiply with 2x and with 10. So if I expand safely, first one is 60 minus 18x. That is equal to 50 minus 20x. I bring my x's to the same side, so I add 20 here, add 20 here, so I'll have 2x. And then subtract 60, 50 minus 60 is minus 10. Now I divide by 2 on this side, divide by 2 on this side. I'm left with x is equal to negative 5.